Hi, welcome at this deep dive into creating Android apps. I'm Danny Wind, a long-time Delphi developer. If you've been to the Netherlands, you may have seen me presenting on Delphi, although maybe Amsterdam was more on the top of your list of things to see. In this presentation, we're going to use standard demos, as included in Delphi XE5, as a jumping board to look below the surface of Android development with Delphi. First, we'll take a look at architecture. How does it all work, what files are in there, and what does Delphi do for you to get those files onto Android. Then we'll take a look at the platform, what you need to develop on Android, debugging in the IDE of course, but also how to use Android Monitor for logging. Last, we'll see how easy it is to deploy your app, using permissions and provisioning, things like that. And we finish with a Q&A at the end of the session. Well, first let's take a look at architecture. As you may know, Delphi has one source to rule them all. That means that the Delphi and C++ builder, although that's not available yet for Android, will allow you to develop using one source and compile and deploy to multiple platforms. Kind of like write once, deploy everywhere, which BODE. Well, how is this platform independence coded? Well, in all display of user interface controls, they are done using DirectX or OpenGL depending on platform. So this means that the display of the user interface controls is actually independent of the platform API. Usually in old style Delphi in VCL you're actually calling into the API to display a button. FireMonkey doesn't work that way. FireMonkey actually renders each control on each platform using graphics libraries such as OpenGL and DirectX. And RTL now currently does the same thing for you. So it also shields you from platform specifics. So if you open a file on Android, it's going to use Android file open methods. And if you open it on iOS, it's going to use the iOS code. And you don't really notice that. You just load from file and it'll work magically. The IDE also does another thing for you, because you need to deploy your application to each platform. It does need some packaging. For iOS, it's an APP in a IPA, and for Android, it's a SO in an APK. So it's a shared object library in an APK, an Android package. And how that works, we'll see that in deployment. So how does this Delphi Android code actually work on Android itself? Because Delphi doesn't use the SDK, as you may know. Delphi uses the NDK, the Native Development Kit. Now the Native Development Kit allows Delphi to create binaries that are bare metal and run like real binaries and native code on ARMv7 Neon. So it's directly running onto the CPU. This differs from instance Eclipse, which uses Java and the SDK for its development. Now the benefits of using the NDK are that it works well with the FireMonkey framework. And that makes it possible to do cross-compilation for multiple platforms. Not just Android, but also iOS and Mac OS X and Windows. What you also get is maximum performance out of your CPU. I also get max capabilities because you can actually access all of the SDK. So if there are any Java libraries out there, you can still access those and use them in your native application. And that makes it quite a powerful solution. Okay, well, let's take a look in the architecture demo how this all works. So what files are in there, things like that. Let's go to the demo. Okay, let's take a look at the standard demo included in Delphi XE5, the mobile controls demo. You can find this demo at the documents, Red Studio 12.0 samples, and then FireMonkey Mobile and then controls. This standard demo shows you several controls that you can use for your mobile development, like list boxes and, for instance, segmented controls. It's like a radio group. All you really have to do to get it to run is connect your target device, in this case Nexus 7, and just run it. Connecting your Nexus 7 can be challenging. I've made a video and XE5 Android up and running to show you how to connect your Nexus. And if you're running on the device, you'll see how it actually looks on the device. Here we have the toolbars, here we have the tool buttons, which are styled differently. It's just a speed button with a picture on it. Tabs, you can nest tabs, multiple tabs inside each other. And list boxes. In list boxes you can actually add multiple controls, not just items. And here is the segmented button again, which is basically just a radio group. And some editors. I'm gonna modify this demo, and the item is a multi-select item, by the way. I'm going to modify this this demo to load a file from disk. So let's do that. Let's close it and open the copy of this demo, which I've made under controls here. I'm going to use the memo, it's already in the demo. I'm going to add a speed button and I'm going to style it so it looks like a mobile button. I'm going to style it using style lookup and use the refresh button style, refresh tool button. The memo itself, I'm going to align it to the right, anchor it and align it. And in code, I'm going to load the memo lines from file. So memo.lines.load from file. I'm using a system IO utils to load the file from disk. And what I'm going to do is I'm going to combine a path and a file name using tpath.combine. The benefit of using tpath.combine is that I don't have to actually know if it's a forward slash or a backward slash that's used on the platform. And coderage8.txt. Coderage8.txt is a text file I made previously. Here it is. If I'm going to load from file, from the documents path, I'm going to have to add it to deployment and make sure that Coderage8 is actually in the documents path for Android. And the documents path for Android is assets/internal. Assets/internal/. That's the default documents path in Android. It's a startup/documents for iOS, by the way. Okay. Let's show the files in Explorer so we know what's in it. And then I'm going to build and deploy it and see what files are added in each stage. So first I'm going to build it, and we'll see the Android directory, and under the Android directory there's a debug directory. It contains the libmobile controls shared objects file, that's actually the binary, the compiled binary, and a manifest. And let's take a look at this manifest, Android manifest example. It contains all the permissions that are set by default. You can actually change them using project options. It also adds the activity, and activity is the first form, the main form that's started when you start your app. It has an intent filter and a receiver to communicate with the operating system with Dalvik. Okay, let's deploy libmobile controls.so. Deployment actually means packaging, so it's actually packaging all that assets and binary and classes and all that stuff into one APK, and the APK is placed in the bin directory. Well, the assets, that's of course our Coderage8 file. And let's take a look at the package. An APK is an Android package, and that's actually basically a zip file. Let's take a look. If we rename apk.zip to zip, okay, we just open it, we'll see that all the files that are included inside it. Let's refresh it here, and the internal is just Coderage8, that's the file we added, and on the lib you've got the SO, the shared object library, as well as a GDB server that's used for debugging. Okay, that's basically just it. Under classes, by the way, there's a classes.dex file. It contains some default classes used for Delphi, as well as some basic classes from the SDK in Java. We'll take a look at the DEX file later on. Okay, let's refresh it here. Here we got all the files. The manifest has the settings, the SO is the shared object library, it's actually your binary. The .dex, the class is .dex, that's the Dalvik executable Java classes. And assets, there are writable files that you include with your project. Rest contains all the images and such, like the image you have as an icon. And the APK. Okay, we've seen how that works with the files in a Delphi native Android app. Next we're going to take a look at the native controls. Native controls are actually controls that are partly FireMonkey and partly actually calls into the SDK to show an actual Android calendar or an iOS calendar. There are a number of native controls. They're custom picker, date picker, time picker. They're all native controls, so they actually bind to controls in a given platform. How does that work? Well, they actually access the SDK, and while most of the Android and iOS SDK is easily accessible using RTL and FM, by using, for instance, native controls, not all of it is accessible. But the benefit of using native controls to display a calendar is, of course, that it's easy. You don't need to know any platform-specific coding, and you do get the platform-specific calendar. And you can use the same code across multiple platforms. But you can actually access low-level SDK, as native controls actually demonstrate quite clearly. Let's take a look at native controls and how those work. And in order to look at native controls, I'm going to use the standard mobile controls demo we used earlier. Let's add a combo box. A combo box is actually a picker. So it picks items from a list depending on platform. It will show different control. The prototype bind source, I'm going to use that one to just fill some data into the combo box. Let's bind it here to the combo box, contact name to item text. I've added contact names as prototype data. The mobile controls I made was for Android. We used the get documents path to get the text file inside the memo, as you may recall. And the Nexus 7 was our target. And this time we also want to target the iOS device, just to show the different effect of native controls on the two platforms. So under deployment for iOS, I need to change the code range target path, the remote path, to start up /documents / don't forget the capitalization, it's quite important. Okay, and it's for iOS, it's startup documents, for Android it's assets internals. That's it. Okay, let's run it on the platform. First let's run it on the iOS device. Let's wait a while. And there it is. Okay, on the iOS device, we're going to take a look at how the combo box looks there. Here we go. It's like a scrolling slot machine, really. As much of the controls on iOS are. For the calendar, same effect really. Now let's take a look how this looks under Android and running this app on the Nexus 7. The VNC viewer is quite slow, so animation doesn't go as smoothly as it could be. Reflector is better in that respect. Just put them next to each other and let's take a look. The user interface you're seeing now is actually rendered by FireMonkey, and this part is rendered by the SDK. So the display of the list of contact names is here, that's SDK, and this is FireMonkey. And this is SDK again, rendering the calendar on both platforms. And that's using the same code. So there's no difference in code for us actually. And the loading of the memo works as well. Okay. Let's take a look at how it's coded internally. So we're going to dive into the calendar edit. And the calendar edit is based on a custom calendar edit. Let's go in there. Here we go. And the calendar edit internally has a date time picker, a custom date picker, custom date time picker. And the custom date time picker is actually the interface class on the Delphi side to the date picker and other pickers on the platforms. So for iOS it's fmx.pickers.iOS, and for Android it's fmx.pickers.android. Let's take a look at the Android code. Let's open this one here. There you go. Open file. Okay, the first thing it does is it registers the picker service, this unit. And that makes the pickers available on the platform. So what it actually does is it creates a picker service and it registers this picker service in the platform services. And that means that platform services actually knows whether a picker is available or not, and it can then call that picker. Calling it is actually coded in, let's take a look here. Okay. First, let's take a look at the create. Here you can see that the create actually requests whether the platform service is supported, and if it is, it creates it. And on show, it actually does a do pop up, and the do pop up really shows the SDK version of the calendar or the combo box, or in this case the calendar, of course, calendar edit. And that does a show, and the show itself, this does a call in the user interface thread of a named, an unnamed procedure, an anonymous method that actually shows the native picker with this implementation, the J-based datetime picker. The J-based datetime picker is actually included in the classes.dex. And it's a Embarcadero encapsulation of a native picker on the Android SDK. And pickers are created using the factory, native pickers factory, which makes it easier for the Embarcadero guys to actually create pickers as needed. And you can actually see the mapping here. It's mapped to the Java signature com Embarcadero FireMonkey pickers data picker factory. And there's a create data picker. Using these examples, by the way, you can actually code some SDK calls yourself. Brian Long will show in his part of the demo for Android how to access the SDK. The style lookup here does not influence the actual calendar edit that's called from the SDK. Instead, it just influences the standing control. Now we've taken a look at native controls. Let's take a look at the platform we're running on. Each app in Android is actually run in a separate process, and each process has at least one and only one Dalvik virtual machine. What actually happens when your Android app is run, in case of Delphi, is that it reads the Android manifest. There it finds the native activity that's registered there, as we've seen in the files earlier. And that native activity is then started, and an activity is actually a form in Android terms. And that main form is then run, and your Delphi app at that point is running bare metal on the ARM v7 CPU. This Dalvik VM is also used to run some SDK specific code that's included in the classes.dex, and that's actually used for native controls, for instance. Okay, in order to get to the device, Android has devised a Android debug layer, the ADB. There's an ADB daemon, a server and a client, and the client and server actually run on your operating system on your Windows side, and the ADB daemon is running on your Android tablet, and they communicate using TCP/IP or USB connection, and that allows you to do shell control of your Android device, but it also allows you to put files onto it. Delphi actually uses ADB to place the APK. to install the APK. And the ADB also allows you access to the debugging capabilities of your app. In this case, for Delphi, it's a GDB server, and the GDB server is used from the Delphi IDE debugger to actually debug, like looking into exceptions, tracing, watches, threads, breakpoints, CPU disassembly as well. And this GDB server, as we've seen earlier, is bundled inside the APK. So each app is actually using its own version of the GDB server. There's also another method of using the Dalvik Debug Monitor Server to look at the processes that are running, at the process that's running, using the Dalvik virtual machine as an entry point. The Dalvik virtual machine actually has a port open, and that's used by the Dalvik Debug Monitor Server to access the process information, CPU information, memory usage. You can also use logging. You can request a log call into the Android SDK, and that gets logged in the Dalvik Debug Monitor Server. That's actually quite a useful feature. You can also use it to analyze the network traffic for each app. There are a number of useful features in there. Well, let's just take a look at all these features and in a demo. For this demo, we'll be using tab slide transition from the sample projects. It's just a simple project that shows you how to use multiple tabs in the user interface. It's over here. Okay, tab slide transition. On creative tab slide transition, we check for the existence of a virtual keyboard. We change the user interface accordingly, so scrolling up and things like that, using a scroll box. The check itself is using supports platform services, and then check for keyboard toolbar service in this platform services. So if it's available, add a scroll box. In the on change of the first edit, we prevent going further into another tab by disabling a button that's connected to an action if there's no text inside the first name or last name. I'm going to debug this using the Android Debug Monitor. For that, I'm going to make an extra connection using the Android Debug Bridge. With ADB devices, I can see the Nexus 7 is connected, and I'm going to request its IP address, and that's that. And then I've got to change it to TCP/IP mode. You have to wait a little while for it to come up again. There it is. What I've done now is I've connected the ADB using TCP/IP on port 555. Now I'm going to kill the server and I'm going to reconnect it. You're setting ADB host to the IP address I just requested with shellnet SCHG. I can now restart ADB. And it will connect using USB, because it's still connected on USB, as well as connect using TCP/IP. And the USB one is the one with the long number, and the emulator, that's actually the TCP/IP connected Nexus 7. Let's start Android Debug Monitor, and you can see them both here. So although it says emulator 5554, that's actually the TCP/IP connected Nexus 7 device. In this window here, below here, you can see log entries, and we're going to add some code to display a log entry in that window. We're going to use the logging service and request the platform if the logging service is available. So we're going to use IFMX logging service as an interface, and the same code we used for the keyboard. So if the platform services.connect current, and that gives you the current platform services pointer. If it supports a platform service of type logging service, IFMX logging service, if it does support that, it will give you back the interface to this logging service. And we need to cast that to iInterface, so it's iInterface logging service. Okay, if it's there, we can use it to log it. We're going to use logging service.log, which uses the which uses a format string. Let's just add the time as well as the text that was entered using the sender parameter. And this is going to display in the logging window of Android Debug Monitor. Okay, let's check. Yeah, we're still connected to the Nexus 7 using USB in the IDE, and I'm going to connect using TCP/IP in the Android Debug Monitor, allowing them to debug simultaneously. In the Debug Monitor you can also see this memory usage and some other things, but these are only available when there's actually a debuggable process. We're going to switch console to DDMS, so we can actually see the DDMS messages of the Dalvik machine, and here we can see the log messages. Okay, connected. I've run the VNC server in the background, and I'm now connected using VNC. You can see it here, the VMLite VNC server and Surface Slinger. That's actually just displaying the VNC viewer, so that has nothing to do with the application itself. Memory usage, you can see most of the memory is still available, it's blue. And CPU load for our process is the com.embarcadero. Tab sliding project is just 2%. And in the logcat you can see all messages that were logged when running this process, running this app. Okay, let's put some data in there. Let's type in code. The first letter you're typing in, you'll see them appearing in the log window. That's code rage 8. So the logging code is actually working. And while you can now see logging in the Android Debug Monitor, I can also simultaneously debug in the IDE. So here you see code rage 8. So let's debug in IDE as well by placing a breakpoint. Okay. And back to the user interface. Let's put an H in last name. And it's going to add stop here at the breakpoint. F8, step to the next one. It's not logged yet. But if I step over this one with F8, it's going to be logged here. You see? You won't be seeing it in the user interface just yet because it's not idle and it's not updating the user interface just yet. If I run it now, it will show up in the user interface. So you see you can actually use IDE debugging using USB and Android Debug Monitor using TCP/IP, which is quite a handy feature to have, because otherwise the Android Debug Monitor would steal the debug interface from your IDE. That would only enable one of the two instead of both. I'm going to change the logging service into code that I wrote into the more simple log. In fmix.types there's actually a log function, log timestamp in this case, because I want to add a timestamp, and that does the checks for the platform for you. So as a Delphi programmer you've got a way to write this code a lot easier. Here it is. The monitor, by the way, it's on your installed SDK on the documents, Red Studio 12 and then platform SDKs, the SDK bundle, and then it's there under tools. And you can actually use monitor.bat, but you can also just choose the correct monitor, in my case the x86-64, and just start that one. And after you've been debugging your app, you want to deploy it to multiple devices. There's actually a number of choices you have for deployment. You can just deploy it to a single device with a USB connection or a TCP/IP connection, as I've showed. You can also deploy it using the App Store. In that case you have to sign your app using a self-signed certificate that you can generate from the Delphi IDE. Another option is to self-deploy it. Just build and share your APK, whether it's signed or unsigned. Place it on a website, for instance, and instruct your Android user to use Chrome to navigate to the APK, and you'll just be able to install it from there. If you're going to use a signed APK, you need to create a certificate. That's under project options, where you can actually create an Android application store key store file, and that key store file is created using a password and then bound to your application. As soon as you use this to go to Google Play, Google Play will bind your application and your key store file one-on-one. So if you lose the password, you won't be able to update your application anymore on Google Play. So don't lose the password. You have to set some permissions. It's advisable to set the minimum set of permissions available. If you're using GPS, you have to use coarse location and fine location in the settings. And there's actually a setting to brick the device. I wonder if it will be allowed in your Google Play Store if you set that permission, but who knows. For targeting the devices in Android, most Android versions are supported. As you can see from this pie diagram, the largest part of the Android versions are supported. But keep in mind that Android for Delphi XT5 for Android actually compiles to ARMv7 and requires Neon. That means that not all devices are actually supported, because not all devices have Neon. There are some ARM7 devices that do not have Neon, and there's still some ARMv6 devices out there as well, and those won't run. Luckily, we're heading towards ARMv8, and in ARMv8 the ARMv7 instruction set and Neon is mandatory, so any ARMv8 device will run perfectly, as well as any ARMv7 and Neon device, of course. That's for deployment to devices. If you're going to run and debug on your own device, I'd advise buying a Google Nexus. It's easily the most accessible device for a developer. It has developer images, developer packs for drivers. It basically has all the features and software packs available by Google for your convenience as a developer. You can actually still use another device. It'll work just fine using a Sony or a Samsung, provided you have an ADB debug driver available for your phone or tablet. Let's take a look at deployment using a demo. The demo we are using is actually the location demo. The location demo shows your current location using a GPS sensor. Let's make it a Google Nexus 7 format and change release parameters. So we're going to set that to release. The verified target is Nexus 7. In the release, we're going to set users permissions as well as provisioning. Let's start with users permissions. What we need to use is the coarse and fine location. Coarse location is Wi-Fi based and fine location is GPS based. We also need internet access because we're using Google Maps, but we don't need read calendar, nor external storage, nor phone state, nor write calendar, nor write external storage. So actually we just need 3 permissions, that's all. In provisioning, we're going to create a new key store. And this key store is going to be bundled with our location demo project. I tend to store the key store in the directory of the source code, because I tend to create 1 key store per application. It's not mandatory, by the way. You can actually share a key store for multiple applications, because you can add multiple aliases to 1 key store. But I think it's easier to just create 1 key store per application. And the alias is location demo. I'm using the same password here. You could use a different password, of course. The alias is used as your public and private key pair, and it's used to actually sign your application. Okay, that's done. Let's take a look at the alias info. here it is. You can see that it says an MD5, SHA1 and SHA265 keys. Okay, now this key store is going to be used for packaging the SO in the APK and signing the APK. So let's build it first. After building, what we have is actually a binary as well as a manifest. Let's show the manifest here and release, and there's the manifest. The manifest contains the users permissions that we just set, such as course location, file location, internet. You can edit your manifest here and use that one for actually deploying. So we can change install location to internal only. Of course, you can also do that using project options and going to version info and change it there to internal only. Now we save this NRO manifest. It's going to be used with the deployment step of our activity. So let's deploy it. And after deployment, what we have is an actual APK. And the APK is signed using our key store and alias. And it's here. Now for deployment, I'm going to use our own website. Just placed it there earlier, so we can just load it from Chrome. You can see it here. If I click on location demo project, it's going to download into a Google Nexus. And after that, if I click it in the downloads, it's going to ask for installation. It's blocked per default, so you have to change the setting. And that setting is allow unknown sources of apps. This means that you're allowing apps and that are not placed in the Google App Store. After that, I'm going to go to downloads and click it again. And now it's going to install. As you can see on privacy, it's just using course location, file location, internet. But it's going to install just fine. So we don't need to do anything extra. The app's been installed, let's open it. And let's check if it works. Okay, here we go. The GPS location and the sensor is accessible. If for any reason the GPS sensor is not accessible, please check your permissions. And that's our demo for deployment. Okay, thank you for listening to the deep dive into creating Android apps. If you have any questions, now's the time. Here's our Q&A starting right now.